Hi, Mr. Kubuske again. Last time we got together, we talked about how to calculate molar mass, which is the mass of an entire molecule. Today, we're going to talk about how to calculate percent composition using molar mass. So in other words, we're going to calculate how much of the entire molecule of H2O is the H. How much does the H take up compared to the entire mass of the whole thing? So the percent composition, how much of the whole thing does it make up? Okay? Now, the two examples we're going to use today and the worksheet you're going to use today are all based on the molar mass problems we did last time in class. So I'm going to use the same two examples we did, and on your worksheet today you're going to do the same examples from last time. So you're going to have a lot of the numbers that you need. You just have to learn the formulas and how to do the calculations. Okay? But what I'm going to show you is how to calculate them if you didn't have that information, because on the next worksheet you'll have to do both kind of combined. Okay? So we'll start with H2O, okay, and I'll give you the steps on exactly what I'm looking for here. Okay, so first things first, we're going to identify how much of each. Okay, and again, we learned how to do that when we did molar mass. All right, but we're going to simplify it today. Okay, when we do ours. So I have 2 hydrogens and I have 1 oxygen. Easy enough. Okay, now I'm just going to skip the step where I wrote down the atomic masses and did the multiplication, because you know that I need the atomic mass of hydrogen multiplied by 2. So 2 times 1.00, and I'll put that down here. You don't have to do that, but I'll put that just for our reminder's sake, is 2.00. 1 times 16.0 is 16.0. When I add those together, I get 18 grams per mole. Okay? Now this is an important number, because this is the mass of the whole thing that we're going to compare all of our other numbers to. Okay? So that's the old stuff in the black there. Let's do the new stuff in red. So I want to calculate the percentage, so put my percent sign, of hydrogen. Percent hydrogen. Now I do that by using the amount of hydrogen, 2.0, divided by the amount of the whole thing, 18.0. And multiply that number by 100, because percentages are always multiplied by 100, and I get my answer. So 2 divided by 18 times 100 is 11.1% hydrogen. And I have to have that whole label, percent hydrogen. Let's do the same thing for oxygen. So percent of oxygen, it's 16.0 divided by 18.0 times 100. And remember, the 16 came from here, the 18 came from here. So just oxygen compared to the whole thing. When I do that, I get 88.9% oxygen. And if I did it correctly, I should get, when I add my percentages together, 100%. Or something close to it, usually like a 99.9 or 99.8 based on rounding. All right? Let's do one more example. We'll do the same one from last time. So I have 1 Ti, I have 4 MNs because the 4 gets distributed, and I have 16 oxygens because it's 4 times 4. 1 times the atomic mass of Ti would give me 47.9. 4 times the atomic mass of Mn would give me 219.6, and 16 times the molar mass of, atomic mass of oxygen would be 256. And I add those together, I get 523.5 grams per mole. So now I have all the information I need in order to do my problem. Okay. So for percent Ti, 47.9 divided by the whole thing, 523.5 times 100. And that'll give me my percentage of 9.1% Ti. Let's change the color so you can see this a little better. Okay, my percentage of Mn would be 219.6 over 523.5 times 100. Gives me 41.9% Mn. And then lastly, percentage of oxygen is 256 divided by 523.5 times 100, because it's a percentage, okay, and I get a total of 48.9% oxygen. Now, when I add those up, when I do the totals, it doesn't equal exactly 100, but again, that's okay. It's because of rounding. I took everything to the tenths. Obviously, the further down you would go, the more accurate your number would be, the closer to 100. But this is acceptable. These are acceptable answers. Okay. So again, this is calculating percent composition using molar mass. Okay. Hope you learned something. Good luck.